Welcome back to Broken Linux, Episode 8, filmed right here on the console. A routine patch reboot, and ProdWeb01 comes up in emergency mode. SRVI data failed to mount. Local file systems dependency failed. Everything's on fire. Except, and this is the part I want you to hold on to, the root disk is completely fine. The system is alive. So what actually broke? So let's set the scene. ProdWeb01 is a straightforward web server with a second disk mounted at HSRV data. Nothing weird in the changelog. No console errors before the reboot, just the monthly patches. But 3 weeks earlier, storage swapped that data volume in from a snapshot, and nobody wired that fact back to the server config. The machine kept serving traffic the whole time, so nobody noticed. Because here's the trap. A file system that's already mounted doesn't care what fstab says. That file only gets read at boot. So here's where I want you to pause the video and actually think. You're sitting at a root shell. Emergency mode. Root file system is read-only. Systemed is telling you local file systems failed. And as far as anyone documented, nothing changed during the patch window. What do you type first? Don't reach for a fix yet. Just decide where you'd look. I'll wait. Most engineers, under pressure, reach for hardware first, so let's do that and watch it waste our time. fsc against the root device, read only with -n, comes back clean. 84,000 files, no errors. lsbook and balkid on the second disk show it right there, 50 gigs. ext4, label intact. 2 commands, about 70 seconds, and we've confidently ruled out things that were never broken in the first place. So let's stop guessing and ask the system itself. Systemctl failed, lays it out in 3 lines. Amount unit for HSRV data, a device unit tied to a specific UID, and local fs.target. All failed in that order. And the journal confirms it. Timed out waiting for device, 90 seconds, then it gave up. Notice what system is actually telling us. It wasn't looking for a disk. It was looking for one very specific UID that never showed up. And this is the piece most people get wrong. A UID doesn't belong to the disk, and it doesn't belong to the slot. It belongs to the file system itself. The slot? Dev VDB survives. The size survives. Even the label can be put back. But the moment something regenerates the file system, whether that's a reformat, a snapshot restore, or a recreated volume, you get a brand new UID. Everything looks identical from the outside. Everything except the one string fstab actually cares about. So how do we make sure this never wakes anyone up again? 3 fixes ranked by how much sleep they save. The heaviest one is the smallest edit. Add no fail and a short device timeout to that fstab line, and a missing data disk becomes a warning instead of an emergency prompt. The box boots, and you fix it over SSH like a civilized person. Second, get in the habit of running findmnt. Verify, not mount A, because mount A will happily lie to you about anything that's already mounted. And third, when a volume is designed to be restored or re-imaged, mount it by label, a name you control, instead of a UID the file system controls. And underneath all 3, after any change to storage, networking, or boot config, reboot on purpose while you're awake and expecting it. Now, there's a catch that bites Cloudfleet specifically. Every fix I just described assumes you can actually log in at that emergency prompt, and on most cloud images, you can't. The root account is locked by default. So systemed asks for a password that doesn't exist, and your recovery plan ends right there. What's left is uglier. Reboot, interrupt grub, edit the kernel line to boot straight into rescue target, or even init bin bash, then remount the root readwrite and fix all fstab by hand. So test your console recovery before you need it, because on half the fleet, the door you were counting on is already locked. That's it for episode 08. Next week, a puzzle that looks impossible on the surface. A file sitting at chmod 777, world readable by every definition, and yet cat refuses to open it with permission denied. If that sounds like it breaks the rules of Unix, good. It doesn't, but figuring out why is going to teach you something about Linux you probably haven't thought about in years. Subscribe, and I'll see you at the next console.